2, 2, yeah. That arrow means it's going to keep going forever, and it's not positive infinity because it goes up. It's positive infinity because it continues to go to the right. And the fact that it's going up makes no difference. Okay, so now the opposite. Where would f of x be less than 0 on the picture? How would we tell from the picture?
If it's below.
Below. So, where would that start? And you can never include infinity, whether it's positive or negative. So that's not even a question. To what? Negative 3, right? Doesn't include negative 3. No, because negative 3 is on the x-axis. Where's the next one pick up?
0.
To what? 2. And the same reason that you're not going to include those. Now, how is 4 different than 2?
It's also including if it's on the x-axis.
Yeah, it's going to include the endpoints here. Except for which one? Yeah, you can't include infinity. And it's going to be the same here. 3 and 5. Those are the same except for this includes 0. So it will include these endpoints, but it won't include infinity or negative infinity. So we just rewrite it just like we had it, only we put brackets. Okay, it talks about something you learned in pre-AP Algebra 2, but probably didn't learn this method. So we'll go over this method again. This method is the exact same thing we just did. The only difference is, what if you didn't have a picture? We want to be able to figure out where it's above the x-axis and below the x-axis without having to graph it every single time. That's going to be a pain. And if they had the graph for us, awesome. But what if they didn't? So we're going to learn how to do that without. All right, so first step is to completely factor the polynomial. Okay, so we already did this. We already completely factored the polynomial. We do, it was x plus 3, and x minus 2. But notice it's an inequality now. It's not equal to 0. It's greater than or equal to 0. That's okay. We can still figure this stuff out. Set each factor to 0 and find the number of zeros in the function. Draw a number line that is divided into segments using zeros. All right. There is a reason for these number lines. These, you're about to see, turn into sign charts. And sign charts are like the backbone of calculus. So there's a reason why in pre-calculus we're doing it this way. Plus, it's very helpful. So we know our zeros are, we have x equals 0, x equals negative 3, and x equals 2. You did notice it's the exact same equation that we had up at the top. Okay, so putting those in order, we have negative 3, 0, and 2. And they don't have to be spaced apart like they're supposed to be. Just space them out. Just make sure you put them in order. Then number 3 says, choose a number from each interval and determine the sign of each factor of a polynomial based on the chosen value. This will enable you to determine if the entire polynomial is positive or negative on the interval in question. That sounds like a bunch of gibberish. What that means is, so our first interval would be from negative infinity to negative 3. So pick a number, any number, between negative infinity and negative 3. Now, keep in mind, you're going to have to do some math with this number.
Negative.
Okay, negative 4. You could pick negative 5 million, but I don't want to do that math. And I don't figure you do either. So I'm picking x equals negative 4. Now, we're not going to figure out what the answer is. All we have to think about is it positive or negative? So we're going to take that negative 4 and we're going to plug it in to each of these factors. So if I plug negative 4 in for x, obviously that's negative. If I plug negative 4 into x plus 3, will I get a positive or a negative answer? Negative, because negative 4 plus 3 is negative 1. And if I put negative 4 into the next one, negative 4 minus 2, do I get positive or negative? Negative. So if I multiply 3 negatives together, what do I get?
Negative.
A negative. So I just put negative there. And you can write that out, negative, if you want to. I'm going to circle this just so I don't get it confused with any of my other things. Now we do the same thing. Between negative 3 and 0, pick a number.
1.
What?
Negative 1.
There we go. And determine, when you plug it in, each factor is going to be positive or negative. So obviously the first one's negative because I'm putting it in for x. What about the second one? Positive. And the third one? Negative. So what's this going to be? Positive. Multiply negative times positive times negative, I get a positive. Have I lost anybody? Okay. Pick a number between 0 and 2.
Pardon the interruption. This announcement is for the students. Tomorrow will be early dismissal, a little earlier than normal on our virtual day for Wednesday. We'll dismiss at 11:30. And then on Thursday, we are dismissing at 12 o'clock. So if you don't ride a bus, make sure you notify your parents or your ride to let them know to be here. And parent-teacher conference will be from 2 to 6, and the teachers will get in touch with your parents. Thank you.
2 to 6? That's not right. It's 2 to 8. He's about to get on there and say 2 to 8, I think. Either that or they're letting us go home early.
Teachers, don't get excited. It was 2 to 8, not 2 to 6.
Man! Sorry. That was wrong. All right. So a number between 0 and 2. 1. All right. So if we plug in 1, so I get, what is it? Positive. Positive, positive, and negative. So that's negative. And then the last one is to infinity. So what do you want to plug in for x?
4,000.
Okay, let's do it. No, it's okay. And so the first one is
Positive.
positive. Next one? Positive. Next one? Positive. Okay. We can still do it. Not like we're having to find an answer. We're just figuring out if it's positive or negative. Okay, so that's helpful. All right. Number 4 refers to the original inequality sign. In this particular Example, the inequality is greater than or equal to, which means the solution will be the values that make the polynomial equal to 0 or positive. Write the solution intervals. So it is greater than or equal to 0, which means non-negative. I can't just say positive because 0 is not positive. So, where it's positive is here and here, right? And since it's or equal to, does it include the endpoints?
No. Yes, sorry.
Yes, that's okay. If it's or equal to, it does include the endpoints. So it's between -3 and 0 and to infinity, but you can't include infinity. Notice that's the same thing we had up there on D. Right here. Same answer here. Same answer here. So we figure it out if we had a picture or if we didn't. We can still figure it out. So let's make it closer. Okay. We will stop there. What I will do. Are we in school Friday?
No.
No. Okay, but we have a digital. Okay. Okay. I'll figure this out. Okay. So we'll figure out something. Okay, so for tomorrow, when y'all aren't in here, we will just work on homework 18. And then you'll be here Thursday, so we'll talk about that Thursday.